Algebra class. This is just a video going over section 11.3, which was on special right triangles, and I'm just going to do a few examples covering the two different types of special triangles we learned about, the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. So this is just a review on the 30, 60, 90 triangle, which is where I would like to start. If we go back to when we learned about the relationship between the 30, 60, 90 triangle, it's nice because when they give us the short leg of the triangle, which corresponds with the 30 degrees, that is what we consider S. And in relation to the long leg, we can find out the long leg when given S because it's S times the square root of 3. And the hypotenuse is easy to find too because it's S times 2. So we can find just about any side of the triangle when we're given at least one side. So let's try our first example. Definitely pause the video, see if you can work it out on your own, and then go back to see if you can do it together. So at first it just says find the missing lengths in the triangle, example 1. So we know that it's a 30, 60, 90 triangle because we have our square, so we know it's a 90-degree angle. We have 30, so by default the other measurement is 60. And we were given that the short side of the triangle right here, the short leg, is a measurement of 5. So we know right away it's a 30, 60, 90. S in this case is equal to 5. And now it's just a process of going through and applying the different formulas to find the different lengths. So our short leg is 5, which means that our long leg would be S times the square root of 3. In this case, S is 5, so it's going to be 5 times the square root of 3. And our hypotenuse is just S times 2, which is going to give us 10. So we were easily able to find the long leg and the hypotenuse by when just given S, which is equal to 5. The next example is very similar, but in this example they gave us the measurement of the long leg instead of the short leg. Again, we're dealing with a 30, 60, 90 triangle. We know that the short leg must be 9 because of right here we're given that the long leg is 9 times the square root of 3, but when we apply our formula we know that it's really S times the square root of 3. In this case, S is 9. So we know the long leg, which was given to us, 9 times the square root of 3, and therefore the hypotenuse is just S times 2, which will give us 18. Find the missing lengths of the triangle. This one is a more challenging problem because at first we know that it's a 30, 60, 90 by just looking at the measurements given, but the side length given is the square root of 27, and that can be confusing. But since we've been practicing simplifying radicals, let's go ahead and do that. Let's look for a perfect square within 27. So 27, and we know that 27 can be broken into 9 and 3, and 9 is a perfect square, and so 3 will remain underneath the radical sign, so we'll have 3 times the square root of 3. Well, that corresponds with the way our formula is written, so we have 3 times the square root of 3, which would mean that S must be 3 since 3 is the coefficient out front of the square root of 3. So then to find the hypotenuse, it's just as easy as plugging into the formula. 3 times 2 is equal to 6. So the hypotenuse is equal to 6, and the short leg is 3. Make that look like a 6. So now we're going to move on to the 45, 45, 90 triangle, which is very similar, but in this case we have both sides are the same length, so we're going to have S as one leg and S as the second leg, and to find the hypotenuse all you do is S times the square root of 2. So it says find the hypotenuse of the triangle when we're given that s is equal to 13. So right away we can say that the other side is equal to 13 as well. And then the hypotenuse must be 13 times the square root of 2. And it's as easy as that. This one's a little bit more challenging. It says, find the missing lengths of the triangle. The example, this is for example 5. Given a 45, 45, 90 triangle, what is the length of the legs if the hypotenuse is given to be the square root of 128? So, in this case, I would draw my triangle just to give myself a visual. The problem states that it is a 45, 45, 90, so this is going to be our 90 degrees here, and these are going to be our 45s. And it told us that the hypotenuse was the square root of 128. Well, our goal is to find some number times the square root of 2. So let's try and simplify 128, which is going to be 64 times 2. And it just so happens that 64 is also a square, a perfect square. So we're going to have 8 outside of the radical, and 2 will remain inside. So this looks a lot like what we were looking for. So therefore, we know that s must equal 8, since 8 times the square root of 2 is the hypotenuse. This was a rather quick video, but like I said, these types of problems aren't usually that difficult. If you're still having trouble though, you have a couple different options. Try the exercises on page 598 and 599 in the big green book, and also look at the different exercises within Investigation 5.2. And also remember that I'm available during home base and during periods 9 and 10. Just let me know if you have a study hall and you'd like to work with me. And also, if none of those options work, I am going to be doing the BOT program. So I know that you might not need the extra help, but just to sit down and have a tutoring session with me, I will be available then. So just let me know if you need any extra help.